Find the area of the triangle if the tangents at the point alpha comma beta to the circle whose equation is x squared plus y squared equals to r squared cuts the axis of the coordinates in A and B. Let us begin. Let's try to understand the problem graphically first. Now here we have a circle which is centered at the origin because the equation x squared plus y squared equals to r squared clearly tells us that our circle will be at the origin and the radius will be r unit. Now let us suppose that we have a point on the circle. Let's say this is the point C having the coordinates alpha comma beta. Now we have a line which is tangent to the circle at point C, and also it's in tangent to the point C in such a way that it also cuts off axis and it also cuts off the x-axis at point A and y-axis at point B. So as is evident in the diagram here, the tangent line cuts off the x-axis, let's say at point A, and the y-axis at point B. Our goal will be to determine the area of the triangle OAB. Okay, so what we'll do, we'll try to find out the equation of the tangent line. Once we have the equation of the tangent line, we can define the coordinates of point A and point B using that equation. And once we have those coordinates, we can easily find out the length OA, which will be the base of the triangle, and OB, that will be the height or the altitude of the triangle. And we can easily calculate the area of the triangle. So let us begin. So here what we'll do, we'll start with the given equation of the circle. So here we have x squared plus y squared equals to r squared, but we'll transpose r squared to the left hand side. The reason why we're doing this, we're going to compare it with the general equation of a circle whose equation is given by x squared plus y squared plus 2 times gx plus 2 times fy plus c equals to 0. And when we compare, we find that the value of g comes out to be 0, f will be equals to 0, and c will be equals to negative r squared. Now using the value of g, f and c, we can find out the equation of the tangent line. To find out the equation of the tangent line, we'll be using the point form. The point form is going to help us obtain the equation of the tangent line, which is generally given by x times x1 plus y times y1 plus g multiplied to x plus x1 added to f times y plus y1 plus the constant c equals to 0. Now here x1 comma y1, that's correspond to the coordinates of the point of contact. So in our case, we have alpha comma beta, that's the coordinate of point C. So this tells us that the value of x1 is going to be alpha and the value of y1 is going to be equals to beta. So let's substitute this. We're going to get alpha x plus beta y. Now the third and the fourth term is going to go to 0 because g and f are 0. We are left with c. So c will be negative r squared. This will be equals to 0. And this is going to be the equation of the tangent line, which is tangent to the circle at the point C having coordinates alpha comma beta. Now that we have the equation of the tangent line, we'll try to find out the coordinates of point A and B. So let us suppose that the coordinates of point A, let it be denoted by a comma 0. We have the y coordinate value 0, the x coordinate is a. For B, we will suppose that the coordinates be 0 comma b. Now we'll try to first find out the coordinates of point B. Now clearly coordinates of point A first. So point A having the coordinates a comma 0 lie on the tangent line. If it lies on the tangent line, that means it's going to satisfy the equation of the tangent line, which means that we can replace the value of x with a and the value of y with 0. So we get alpha times a added to beta times 0 minus r squared equals to 0. Which means that our value of a comes out to be r squared over alpha. Similarly, we can say that point B, so point B lies on the same tangent line, which has the coordinates 0 comma b. So point B lie on the tangent line. So that means it is also going to satisfy the equation of the tangent line, meaning we can replace the value of x with 0 and the value of y with b in the equation of the tangent line. So we'll get alpha times 0 plus beta times b minus r squared equals to 0. And this is going to help us obtain the value of b. So b is going to come out as r squared over beta. So if our b value is r squared over beta, we can clearly say that our y-intercept OB value, that's nothing but the value b, which will be r squared over beta. And we, from this particular value of a, we can say that OA, which is the x-intercept value given by a, that will be equals to r squared over alpha. So we have successfully obtained the length of the base and the length of the altitude. All we have to do is multiply them and divide by 2. That's going to give us the area of triangle OAB. So let's do that. So therefore, area of, now the area of triangle OAB will be given by half multiplied to the x-intercept OA times the y-intercept OB. So we have half times r squared over alpha multiplied to OB, which has a value r squared over beta. So our result comes out to be r raised to the power of 4 divided by 2 times alpha times beta. So this is going to be the area of the triangle OAB.